So today I will talk about a very important relationship between Cartesian coordinates in stationary frame and the Cartesian coordinates in moving frame, and that moving frame is rotated about the z-axis, right? So let us have a look at it. So suppose consider a coordinate system. It's like this. It's a coordinate system which I am considering here. So say this is a stationary frame, and let us say it is like this. Say it is a S frame, and here it is x-axis, it is y-axis, and it is z-axis, and it is a S frame, and let us call it is a stationary frame. And let us suppose there is another frame of reference and the origin is coinciding again, but it is rotated about z-axis, means it is like this. There is another frame of reference. It is like this. So it is x prime, and say it is y prime, and say it is making an angle theta with x-axis. So it is also theta. So if this angle is theta, then whole of this angle is said to be 90 plus theta, right? Or in other words, you can say that either you call it as this or you call it as pi by 2 plus theta, one and same thing. So now let us suppose there is a point in space somewhere here. Say there is a point and say this is a point somewhere here. And say it is a point A, and the coordinates of A point is x and y in S frame, and say this frame is the S prime frame, this is the moving frame, sorry, rotating frame, not moving, but let us call it as it is a rotating frame. So, and in the S prime frame, A is represented by x prime and the y prime, and it is a S prime frame. And let us call the unit vector along x-axis is I cap, and along y-axis say it is j cap, and whereas along x prime it is represented by I prime, and say it is j prime. So if I am looking at the particle only in the S frame, in the S frame, OA will remains the same, and let us call it as a R vector, and it will remain same, this distance. So it is represented by xi cap, yj cap. Only simple vector algebra I am applying here. But when it is rotating about z-axis, because it is moving in a plane, it only xy plane is changing, means x and y is changing, but z remains the same. So I am not considering here z, because z will remain the same. So let us call it as like this. But when I am looking at this OA vector from S prime frame, then this is again remains the same, but rather than x, it will become x prime, I prime plus y prime and j prime plus zk. It will remain the same. Now I want to find out the relationship between this x and this x prime and the y and the y prime. So for that, what should I do? Let us try to first of all find this I prime cap is what and the j prime cap is what. So for that, let us do one thing. Suppose we are having a vector is like this. Again, I am considering a coordinate system, and say there is a some point is here, and say its position vector is r. Then how it can be represented if it is making an angle theta with this? Then I will basically generalize this concept here. So in this case, this r vector is basically, this is x distance and this is r cos theta and this is r sin theta. So I can write down it as, because this is the projection of this r along x-axis, so it is represented by r cos theta I cap and r sin theta j cap. This is the projection, this is r cos theta, is basically this distance is the projection of r vector along x-axis. And what is r sin theta? This r sin theta is basically again projection of r along y-axis, so it is r sin theta j cap. So now let us try to look at this part. If I try to look at I prime, so I prime can be written in terms of I cap and j cap, but here what is its value? It is the magnitude of this one, means magnitude of this and the cosine of the angle between with the x-axis, because it is making an angle theta. So what is it? It is I prime cap, its magnitude and cos of theta, plus I prime cap sine of theta. So what is the magnitude of unit vector? Is always 1. So its magnitude is 1, its magnitude is 1, so it is cos of theta I cap sine of theta j cap. Similarly, if I try to look at j cap prime, then it is again the magnitude of this vector and cosine of the angle between this j prime and x-axis, because it is making an angle theta with this one, so it is 90 plus theta. So rather than theta, let me put it as 90 plus theta, because it is making an angle, this is the 90 plus theta. Similarly, it is again j prime cap, it is sine 90 plus theta, and here it is I cap and here it is j cap. Basically I am generalizing this concept here for the I prime cap and the j prime cap. So cos 90 plus theta is minus sine theta I cap plus it is cos of theta j cap. So I'm just using these values here. So what I'm getting here I got that this I prime cap is equal to cos of theta I cap plus sine of theta j cap. Similarly, this j prime cap is equal to minus sine theta I cap plus cos of theta j cap. I just using these values here now. Yeah, well, let me do it. Let me make it little smaller. Yeah, now it's better. So how this can be written as? Also we know that this is r, both are similar, so that means, in other words, I can say that this x I cap plus y j cap plus z k cap is equal to x prime I cap plus y prime j cap, and both prime should be there, z k cap. This will cancel out with it because it is only rotating about the z axis, so z will remain the same. So I can write down it as the x I cap y j cap is equal to x prime I prime cap y prime j prime cap, and if I put these values here, then what we are getting? We are getting that it is equal to x prime cos of theta I cap sine of theta j cap. This is the value of this one, plus y prime minus sine theta I cap cos of theta j cap. That's what I am getting here. And you have to remember this particular relationship for future. This is a very important thing. So let us proceed further. So if I compare, or let me rearrange it, what does it mean? It means that x I cap plus y j cap is equal to x prime cos of theta minus y prime sine theta and I cap plus x prime sine theta plus it is y prime cos of theta into j cap. So if I compare, then this x is basically equal to this one and this y is equal to this one. So therefore, comparing both sides, what I am getting, that x comes out to be equal to x prime cos of theta minus y prime sine theta, and this y is equal to, this is x prime cos of theta, sorry, x prime sine theta plus y prime cos of theta, right? So this is the one relationship. So we got two relationships which we have to remember. Let me go to the next page, let me to new page. Yeah, again come back. There is another relationship that is here. Just a minute. Yeah, let me, this is another relationship. Let me put these together. Yeah, it is from here to FTP space. Come back here. Now these are the two relationships. One is this and another one is this one. What I need? Now I need to find out x prime and the y prime. So for that, what should I do? Say if I multiply this with the cos theta and this with the sine theta, then what will happen? These two will become equal and opposite and it will cancel out. So that means, say this is equation number 1, it is equation number 2. So what I will do? I will do 1 multiplied by with cos theta and 2 multiply with the sine theta, and then all are added together. So what it will become? It is x cos theta is equal to x prime cos square theta minus y prime sine theta, and it is cos of theta, and it is y sine theta is equal to x prime sine theta plus y prime, it is sine theta and the cos theta. So let us add these, so these will cancel out. So what it will be? X cos theta plus y sine theta is equal to x prime cos square theta plus sine square theta, and it will become 1. So I can simply write down x prime is equal to x cos of theta plus y sine of theta, right? So if I put this value from here in equation number 1, so what will become? Because I need to find out now y prime, so that means I have to eliminate x prime. So for that I just using this value from here to in this equation number 1. So what equation number 1 will become? That x is equal to x cos of theta plus y sine theta into cos of theta, means I just put this value here, and minus y prime sine of theta. So what it will become? It is x is equal to x cos square theta, it is x cos square theta plus y sine theta cos theta minus y prime sine theta. But I need this one, so I just bringing this to this side and this towards that side. So it is y prime sine theta is equal to x minus x plus x cos square theta plus y sine theta, and it is cos of theta. So it is, let us take minus x common, so inside it is 1 minus cos square theta is here plus y sine theta, and it is cos of theta, but 1 minus cos square theta is sine square theta, so I can write down it is a minus x and the sine square theta plus y sine theta and cos of theta. So if I divide both sides by sine theta, then y prime will become minus x sine theta and plus y cos of theta, because this sine theta will cancel out when it is taken towards that side. So therefore what I am getting, x prime is equal to x cos theta plus y sine theta and y prime is equal to minus x sine theta plus y cos of theta. Let me go back. Yeah. So let me summarize now all the results here. Yeah. So these are the 3 results which we have to remember. This is for unit vectors. This is for Cartesian coordinates in the stationary frame of reference. These are written in terms of the Cartesian coordinates in moving frame of reference, and that not the moving but the rotating frame of reference, and that is rotated about z-axis. and this is from rotated frame of reference coordinates can be calculated in terms of stationary frame of reference Cartesian coordinates. So these are the three very important results which we have to remember. So I think that's all for today's lecture, and in the next lecture I will use the concept of this to find out the isotropy of space, and that leads to the angular momentum conservation. So that's all for this lecture.